project that the CAAIN is supporting is the development of agricultural autonomous framework. So the framework, really what it is we worked on a number of different autonomous applications in the past, and are currently involved in several different applications. And what we've seen is that these companies that are developing autonomous machines, or our customers, even if it's totally different applications, there was this kind of reinventing of the wheel. Everybody needed to do perception systems and guidance systems and manage missions, and there's a whole lot of time that was spent on developing underlying infrastructure rather than focused on the end application. So the autonomous framework is a platform on which to build customized autonomous machine applications. It's kind of an evolution for us. So I started the engineering and technology portion of JCA. So the company was started by John Anderson about 20 years ago, and I joined the company 9 years ago, starting the engineering group, and that evolved initially with agricultural OEM applications, and then to precision ag, and then to autonomy. So it was an evolutionary step for us where we developed an expertise in first solving problems for OEMs and around agriculture. And us coming from the agriculture implements means that we're always working on the agricultural problem, not on driving and navigation, where a lot of autonomy starts because of the automotive world. And so the focus on guidance and navigation, but we really focused on the agricultural applications, and then evolved towards different levels of application. So we had different projects over the years where our customers, got closer and closer to needing autonomous systems. We started our first autonomous project in 2016 and 2017 with a customer, and saw that there was this need that I've been describing for this increased level of complexity that's integrating robotics, and cloud systems needed a whole bunch of new technologies. It wasn't just an evolutionary change, but a real step change in technology. And so as we started seeing a few of these different applications, realized the strong need for a framework and a platform to build on top of. So that it kind of evolved from our customers' applications over time, and just a progression and down that path. Broadly speaking, the challenges are kind of bringing these different technology paradigms of mobile machine, off-highway, ruggedized system electronics, precision ag and guidance systems, and robotics that are made for different industries, and bringing those all together in a system that can survive agricultural systems, and are suited for the application. So, there's a lot of challenges under there. Specifically, there's challenges in safety, functional safety, and how do you deal with open source software and machine learning type applications in systems that also need to have certain levels of guaranteed safety. So those are challenges that we've iterated on and worked through, and found an architecture and and a method that works to solve those problems together. But there's definitely attempts and failures down that path to kind of evolve and develop the system. We have technology that works well with cloud connected systems, but doesn't also depend on that all the time, because the reality of working in agriculture is that you're working in remote areas, and you're also working on mission critical applications. If someone's putting seed in the ground, for example, at a certain time of year, you don't want to stop that because you lost internet connectivity. So we need to have systems that work, whether you have remote connectivity or not. It does complicate designs, because we have to have local networks and things to connect multiple machines together if that's needed in the system. But we've found solutions for each of those things. But that's always been a challenge within agriculture. We've worked on systems with customers in Europe and in Canada and North America, and in certain applications in Europe, they do have strong connectivity, and so we've developed autonomous systems that depend on an internet connection, and it really simplifies a lot of the connectivity pieces, because when you can't depend on that, then you have to build a lot of local networks and a lot of radio systems and other things. And it's certainly always possible. Technology exists to do it, but it just makes it more expensive. It makes it more challenging, a lot more development. So yeah, the effort to move towards more connected farms, I think, is a very valuable one. One example I can give, because they've unveiled their system, and is with a company called Exact Robotics in France, that we've worked with them over the last year and a half, or a little bit more, to develop autonomous system for vineyard applications. And so they just publicly launched their machine, and so it's a really great success. It's very aggressive timeline. It's addressing real needs in the market, to move to more sustainable agricultural methods in the very near term, as there's restrictions on glyphosate spraying in Europe that are coming into place. And so moving to a autonomous system that can have tillage and other ways of managing, working the vineyards, is really needed and necessary. It's allowed us to accelerate our autonomous framework technology development, which is extremely critical, because of the fast-moving market for autonomy. So over the last few years, and you see it every year, it feels like the number of applications, doubles from the year before, and so that's a real big push in the need for the technology to move forward. And so we've been very aggressive in moving that technology forward, and have, a vision of continuing to do that. And the CAAIN program has been a big support for us to been able to have the engineers and invest in the technology to be leaders in the market with our technology. I see the farm of tomorrow having more automation, not in a way that somebody's, in Hawaii on a beach and the farm's running by itself, but in a way that just makes better use of farmers' time. So I see farmers as being more critical to the farm, not as replacing what they're doing, but just making sure that they're doing the value activities on the farm, and the repeatable jobs that don't need the expertise of the human mind are the things that are going to be more and more automated. So yeah, it's a similar path that you see with automation in factories, but it's a lot more complex, because there's no limits to the factory, there's no bounds, or it's in the open world. So I think it'll be more connectivity, more looking at the workflow of jobs, not just that what does this machine do, but how does this machine connect in the whole workflow of food production. I mean, I've really enjoyed working with the CAAIN group, and I think that has been a really good partnership to help us to move forward with our vision of autonomous framework. I think, the path that we're going down it gives us a unique perspective into the industry, and gives that ability to connect. We very much are a connecting company, and so, I think that is in alignment with the view and what CAAIN's mission is as well. So I think it's worked well there.